Hey snackers, ready for some bite-sized brain fuel? Today's special, a salty Antarctic lake that could unearth a Martian mystery. Let's dive in. No spacesuit required.
Ever heard of a pond so salty it never freezes?
Not your average swimming hole, right?
Not even close. We're talking Antarctica, and this pond, it's called Don Juan Pond. It's one of those mysteries that just grabs you and pulls you in.
And we're going deep on this one.
Yeah, real deep dive. But we've got another one for you, too. A hidden lake, totally buried into the ice.
These are real places, by the way.
Yeah, not science fiction. But what we find out here could tell us a lot about, water. Maybe even life on other planets.
Antarctica, it's often called the most Mars-like environment we have right here on Earth.
Yeah, that's what makes these ponds so fascinating. So Don Juan Pond first, it's in the McMurdo Dry Valley. It's one of the driest, coldest deserts anywhere. And it's tiny, like the size of a couple football fields maybe, and really shallow. But the salt.
Yeah, the salinity is unbelievable. 40%. That's 18 times saltier than the ocean. And twice as salty as the Dead Sea. And it's not the kind of salt you'd find on your table.
Oh.
This is calcium chloride mostly.
So why does that matter?
Well, that calcium chloride is the reason Don Juan Pond stays liquid, even when the temperature drops to -50 Celsius.
Wow.
It's all about freezing point depression.
Okay.
Basically, the salt makes it harder for the water molecules to form ice. The more salt you add, the lower the freezing point gets.
So it's like the salt is its own antifreeze.
Exactly. And this is important when we think about places like Mars. You know the surface is super cold, but if there's enough salt, water could stay liquid underground.
That's wild. So where does all that salt come from in the first place?
That's the million-dollar question. Scientists have been puzzling over that for decades. You know, the old theory was simple evaporation.
Makes sense.
But new research has come up with a couple other possibilities. Maybe a deep groundwater system. Or the surface water tracks.
Okay, let's take those one at a time. The groundwater system first. What makes them think it might be that?
The chemistry of the pond, it's not what you'd expect. If the salt was just from evaporated surface water, it's missing certain elements, magnesium, potassium. So the water and the salt probably come from deeper down, like from a huge aquifer.
An aquifer.
You know, a big underground reservoir of water. And those are exactly what scientists are looking for on Mars.
Interesting. And what about the surface water tracks? What are those?
Well, they're these dark streaks on the slopes near the pond. You know, kind of like what we see on Mars, actually. It's called deliquescence. Salts in the soil absorb moisture from the air, even in a dry environment.
So even though it's dry, those salts can pull water out of thin air.
Yeah, it's pretty amazing.
But how do those streaks get into Don Juan Pond?
When snow melts, it washes the salt down the slopes, and eventually it flows into the pond.
So it's getting salt from above and below. Okay, so we've got this super salty pond in this incredibly dry place. What does that tell us about life in extreme environments?
That's the question, isn't it? And here's the thing. Studies haven't actually found any life in Don Juan Pond.
Really?
But that doesn't mean that similar places are always lifeless. What it does tell us is a lot about the non-biological processes that can happen in extreme conditions.
Okay, I see.
It helps us figure out what might look like a sign of life, but actually isn't, like a false positive.
So even if there's no life there, it's still important to study.
Absolutely. For example, the scientists studying Don Juan Pond, they found a new way that nitrous oxide is produced. You know, nitrous oxide, it's a greenhouse gas.
Right.
And this new way, it doesn't involve life at all. It's a purely chemical process.
Wow.
And that could have implications for Mars, too. I mean, the same process could be happening there, maybe even creating fuel for microbial life.
So Don Juan Pond is giving us a lot to think about, even if it's not exactly teeming with life itself. Now let's switch gears completely. From a pond that's way too salty to a whole world under the ice. Scientists using radar think they found this huge lake shaped like a ribbon under the Antarctic ice. It's like another planet down there.
It really is an amazing discovery. And it shows us that subglacial lakes, these bodies of water trapped under the ice, are all over the place.
But how can there be liquid water under all that ice? It's below freezing down there.
Yeah, it is, but there's geothermal heat. You know, even though the surface is frozen, the Earth's interior is still hot, and that heat can melt the ice from below and create these pockets of water.
So there's this whole network of lakes under the ice warmed by the Earth itself.
Exactly. And these lakes have probably been isolated for millions of years. That makes them really exciting for scientists who are studying, the limits of life. They're pristine, untouched, and could have organisms that are totally different from anything we've ever seen.
It's wild to think about these ecosystems cut off from the world for so long. What kind of life could even exist down there?
Well, it's completely dark, so anything living there wouldn't use photosynthesis like plants do. It would have to rely on chemosynthesis.
Chemosynthesis.
Yeah, like those deep-sea hydrothermal vents we talked about before. The organisms there get their energy from chemicals coming from the Earth's interior. Could be something similar in these lakes.
So they'd be getting their energy from chemicals, not sunlight. That's incredible. But if these lakes have been cut off for millions of years, wouldn't any life down there be really primitive?
Not necessarily. Being isolated doesn't always mean primitive. It can lead to some pretty amazing adaptations. Over millions of years, things in these lakes could have evolved in ways we can't even imagine to survive in the dark, cold, and high pressure. It's like a natural lab for evolution.
Like a time capsule of evolution.
Yeah.
But how could scientists even study these organisms without contaminating the lake? I mean, we wouldn't want to introduce something that could wipe out a whole ecosystem.
Yeah, preventing contamination is a huge concern. Any exploration would have to be done super carefully. Everything would have to be sterilized, the drilling equipment, the instruments for sampling, to minimize the risk of introducing anything from the surface.
So it would be like surgery.
It would be a massive undertaking, but the potential payoff is huge. Imagine studying life that's evolved in isolation for millions of years. It would be like a window into an alien world right here on Earth. And it could help us design missions to explore places like Europa.
Europa. That's a moon of Jupiter, right? The one that might have a huge ocean under the ice.
That's the one. And what we learn in Antarctica could help us figure out how to look for life there.
So we've got these two totally different Antarctic ponds. One's super salty, and on the surface, the other's fresh water and hidden under the ice.
And they both have clues about, the limits of life and the potential for water and maybe even life in unexpected places.
Hey, let's bring this back to Earth for a second.
Yeah.
You mentioned earlier that these subglacial lakes could teach us about climate change. How so?
Well, they contain ancient water that's been trapped under the ice for maybe millions of years. Scientists can study that water and learn about past climates and how they've changed, like a time machine for Earth's climate.
So it's not just about weird life forms. It's about understanding our own planet's past, which can help us predict and maybe even deal with climate change in the future.
Exactly. These places that seem so remote, they're actually connected to the bigger systems that control our planet's climate.
It's amazing how everything's connected. Listening to all this, I can't help but wonder, if we did find life in one of these Antarctic ponds, how would that change our understanding of the universe?
That's a big one, isn't it? A question that people have been asking for centuries. Finding life out there, even just microbes, it would change everything. It would mean that life isn't just an Earth thing, that the conditions for life could be more common than we think, that the universe could be full of possibilities we can't even imagine.
It's hard to even wrap your head around. On the one hand, it would be amazing to know we're not alone, but it would also make us feel pretty small.
It would definitely challenge how we see ourselves and our place in the universe. We wouldn't be the center of everything anymore. There could be other intelligent beings out there,
Yeah.
with their own ways of thinking and experiencing the universe.
Exciting and scary all at the same time. But what if we don't find life? Is all this research still valuable?
Absolutely. Even if we don't find life, the search itself teaches us so much about these extreme environments, about the limits of life, about the ways water can exist in unexpected places. And all of that is relevant to looking for life on Mars and other planets.
So how could we use what we've learned to look for life on Mars?
Remember those dark streaks on Mars? The ones that might be signs of flowing water? And remember deliquescence, those surface water tracks feeding Gondwan Pond. Well, a similar process could be happening on Mars. Salts pulling moisture from the air and creating liquid water, even if it's just for a short time. And where there's water, there could be life.
So even though Mars is so cold and dry, there might be these little pockets of liquid water. Incredible. But how would we know for sure if those streaks are water? And how would we know if there's life there?
That's where Gondwan Pond comes in. By studying these salt-rich environments here on Earth, we can figure out what to look for on Mars. We can look for specific minerals and organic molecules and gases that might be produced by microbes.
So we're using Earth as a model for Mars. Pretty clever. Most people think of Antarctica as just this empty, frozen wasteland. But it sounds like these ponds are windows into a hidden world, full of mysteries and possibilities.
That's a great way to put it. They really are. And they remind us that even in the most extreme places, nature is always full of surprises. Who knows what else is out there waiting to be discovered? under the ice in plain sight, or out in the vastness of space. We just have to keep exploring and keep asking questions and keep pushing the boundaries of what we know.
Well said.
That's it for today's snack-sized exploration. As we gaze up at the stars, remember, the solutions to interplanetary mysteries might just be lying beneath our feet. What do you think? Drop your theories in the comments. We'd love to hear your thoughts. But before you go, here's a teaser. Next time on Cranium Snacks, we're diving into the mystery behind why Sir Arthur Conan Doyle wanted to kill off his most famous creation, Sherlock Holmes. Intrigued? Hit like, subscribe, and ring that bell so you don't miss it.